A one-to-one function is found by interchanging the x and y values of its ordered pairs. So if you have an equation like example 1, f of x equals negative 4x plus 12, and that is a one-to-one function, then it will have an inverse that can be found by switching the x and y variables around. Now, what is one-to-one? I just said a new phrase. If you caught that in the definition, a one-to-one function is a special type of function. Okay, we've talked about functions before. Functions have no vertical repeats, but it goes beyond that. Besides not having a vertical repeat, it also does not have a horizontal repeat. Nothing repeats. So you know how a parabola was a function? We would say this is a function, a basic regular function. The vertical line only hits it once. Oh, sorry about that. So that is a regular function, but it's not a one-to-one function. Function, yes, but not one-to-one function. So to be a one-to-one function, it can't repeat this way either. So it hits it twice, it hits the graph twice, so it's not one-to-one. All right, so if something is not one-to-one, it is not getting an inverse. It has to meet that requirement first. So if you'll see example 3 in your packet, we didn't even work it. We just said, no, it won't have an inverse. We'll not be able to work that because it's not one-to-one. But anyway, this first example is, remember, f of x means y, so y equals negative 4x plus 12. We know this equation is a line. X is to the first, y is to the first. Is a linear equation. I could graph that, a sketch of that graph for you. It starts at the y-intercept of 12. And then the slope is negative 4 over 1, so down 4 over 1. So that is definitely, lines are definitely one-to-one. No repeating vertically or horizontally. So that means, yes, it will have an inverse. The inverse switches, that's the proper way to say it, it switches the x and y's around backwards. So to find the inverse equation of this function, I would say x equals negative 4y plus 12 and solve it for the new y variable. So again, interchange the x and y, and then resolve it. So I'm going to bring the 4y across the line, the x to the other side, solve it for the new y variable, and that is the inverse equation of this original function. Instead of saying f of x or y, we'll say f inverse. Kind of looks like a negative 1 exponent, but it's not. It's different. F inverse of x equals negative x plus 12 over 4. Or negative 1/4 x plus 3. Now, how this is going to look on the graph is every x, y switch places. It switched places algebraically by switching it in the equation, but it also switches on the, when you graph it, every x and y is backwards. So let me show you how this looks on the graph. It's y-intercept is at 3. Its slope is negative 1 over 4. So down 1 over 4. I don't go down 1 enough. Without graph paper, it's hard to make this look just great. But it looks something like that. So the original function, f of x, and then its inverse function, f inverse of x. And those are symmetric looking lines, which I know they're all just straight lines, so they're going to look similar, but this happens with all the graphs that have inverses. The graphs are symmetric looking figures, and they're reflected about the diagonal line y equals x. If I drew a line directly through the origin, and I folded these graphs together, they would meet. Inverse functions always fold along the y equals x line perfectly. Okay? And if the point 0, 12 is on this graph, then the point 12, 0 should be on its inverse. Everything about x and y should be backwards. Furthermore, its domain and range would be backwards, which with this function, it's hard to tell there's any difference because the domain of the line is negative infinity to positive infinity, and so is the range. So whenever you switch those, you're not going to be able to tell that you switched it, but we'll see a function later that will have a specific domain and range issue that you'll be able to tell a difference. Okay, how am I doing on time?
You have 10 minutes left.
10 minutes left. All right, so let's look at the next example on down below. Let's do example 2. I'll go ahead and cut it off there though.